Hello, in this video we are going to see about that introduction to the compiler and phases of the compiler. In the last video already we know about what is the compiling and how the language processing system is works. Now we see the recap of the last session. So in the language processing systems we have our input source program is given into the preprocessor. The preprocessor converts into the pre-processed high-level language program. That high-level language is given into the compiler. The compiler compiles that program and produces output as a assembly level language. That assembly level program is given into the assembler. That assembler converts that into the relocatable machine code, including the library files. So finally the relocatable machine code is converted into the absolute machine code by using the linker and loader functionality. This is the language processing systems. Already we know that. So in that, compiler is one of the translator that translates our pre-processed high level language into the assembly level language. So in this video we are going to see about what is the compiler and how that compilation is done and how it is convert from the high level into the assembly level language in the several phases. So in the compiler we have a the compiler is also the translator. So for that translating it requires 6 phases. Through these 6 phases it converts our high level language into the assembly level language. So the first phase is the lexical analysis, and the second phase is the syntax analysis and semantic analysis and intermediate code generator, code optimizer and target code generation. So in the first phase, the lexical analyzer converts our high level language into the tokens. So in the tokens is a stream of characters. That tokens is given into the input to the syntax analyzer. That syntax analyzer checks whether our token is correct as per the syntax of the given programming languages. So for that corrections it generates the parse tree. So using the parse tree it checks whether our statement is correct or not. So the output of the syntax analyzer is a parse tree. So that parse tree is given into the semantic analyzer. That semantic analyzer verify our statement semantically. That means if there is any type mismatch is there and any type compatibility is there, so that verification is done in the semantics phase. So the output of the semantic phase is also the parse tree. So that parse tree is an annotated parse tree. So in that we have a what is the type of the variable and what is the size and what is the value of the variable. This annotation is done in that parse tree. So that output is given into the intermediate code generator. That intermediate code generator is the important part of our compiler. So it generates our statement high level language into the 3 address code. So why we need that intermediate code is that from high level language to assembly level language direct conversions, instead of that we are using that intermediate code. So that 3 address code, once our high level language is converted into the 3 address code, that 3 address code is converted into the assembly level language, means it is very easy to understand other as an end user. So the intermediate code generator gets the input as a annotated parse tree and create that statement as a 3 address code. So then the 3 address code, it can be in any representation, that may be a quadruple, triples and syntax tree in any representations. So in that we are using the temporary variable, we are writing the statements. So in that we need the what is the registers or the temporary register is there. So that are all the things is done in the intermediate code generator. So that 3 address code, the output of the ICG is given input to the code optimizer. So the function of code optimizer is produce the optimized intermediate and optimized 3 address code. So what is mean by optimized? So in that optimization, it reduces if there is any redundant statements or irrelevant statements is there in our statement. 3 address code means it can be reduced and it can be optimized. So the output of the optimized code is given input to the code generator. So the code generator convert my optimized intermediate code, that means the optimized 3 address code, into the assembly level language code. So what is an assembly code means? That is the use of mnemonics we are writing our 3 address statements. So for example, you have an A is equal to B plus C means that is a 3 address statement. First, using the registers and intermediate representation, the assembler is done. So first we are move our variable into one register. So and again you are going to add means using the mnemonic statements add and move and multiplications, we are generate the assembly level code. So the output of the compiler is the assembly level code. So for these conversions, for every phase it is like act as a translator. So for every phase we have an input and output. If the particular statement is correct, it produces a correct output, otherwise it produces a error statement. So the possible error handling mechanism is there in the every analyzer. So that analyzer handles that error and produces the correct output. So the 6 phases, the 2 terms are common to these 6 phases. They are the symbol table and error handler. So the symbol table and error handler is important to all the statements. So this is the way how our intermediate code is, how our high level language is converted into the assembly level language code. So this is the important function of an and different phases of a compiler for that compilation. I hope you understand and what is the phases and what is the input and output of the phases and how the compilation is done through that each phases. Thank you.